Good morning, everyone. How's everyone this morning? Pretty exciting keynote there. A few presents for people. Thanks so much for joining me today. Simon Alicia. I'm Head of Solution Architecture for Public Sector in Australia and New Zealand. You might remember me for such podcasts as the AWS podcasts. If you're a listener, thank you. If you're not a listener, why not? Sign up, come on. We're going to be doing a lot today. A lot. So once this wakes up, there we go. It's awake now, like most of us. We're going to dive right in. This is a more advanced session, so I'm not going to explain what different services do and all that sort of stuff. You can look that up yourself. We're going to cover quite a lot in a hurry, many different domains. And the objective here is to give you things to take away and actually do. If you walk out of this session with one or two meaningful, cost-saving ideas that you can actually execute in your environment, I'll personally be exceptionally happy. And I'm hoping you will too. That's the intent. And we're going to cover three main domains. We're going to cover operational optimization, infrastructure optimization, and architectural optimization. So there's kind of something for everyone here. Now, the idea here is to show you the money. I want to show you where the opportunities for savings exist. And Werner gave you a whole bunch of new toys today, so you can take those cost savings and invest them in other things if you want to as well. But the idea is to show you where you can get the money. Now, I've tried to make this a bit easy because there's a lot of maths going on here, there's a lot of numbers, there's decimal places, it gets a little confusing. So I'm using this sort of little star system that will show you the types of cost savings. These are real percentages that I'll be showing you today. Now, I'll point out two things. Firstly, all the pricing I'm going to be using is from the Sydney region, just because that's where I happen to reside, so it's easy for me to calculate. Apply your own local region pricing, but the concepts will be the same and the percentage savings will likely be almost exactly the same. The other thing is some of my pricing that I've used will be out of date today. That's one of the joys of working at Amazon. You do all this work, you prepare, and what do? They cut the prices. And I can't be upset about that. That's great news for you. But again, the savings will still remain that you'll see there. So I did want to do the quick wins, the obvious stuff. This is not a basic session, but this is the do not pass go, do not collect $200 unless you do this already. The first thing is use reserved instances for stable workloads. Now, what is the magic rule of thumb that most customers find successful here? Run your system for 3 months. Get an understanding of what the workload actually looks like, spend a little bit of time tuning, spend a little bit of time optimizing, then make your ROI commitment. And your commitment could be a 1 year, could be a 3 year, could be the new convertible ones. Totally your choice. Doesn't really matter, but invest in something for those stable workloads once you understand them well. The second thing that you must do is use consolidated billing because you'll receive discounts with doing no effort. There are many services that are tiered based. EC2, S3, CloudFront. If you consolidate your spend, you automatically get given the discount. Money for nothing, so do it. So it's Thursday morning in Vegas. I am now pretty much 100% Starbucks Frappuccino powered. So I don't feel bad putting this slide up. Let's talk about some of the sweet, good, juicy stuff. So, it's 11 o'clock. I figured this would work. I like these kinds of donuts myself. So we talk a lot about architecture. We architect for availability. We architect for performance, for security, for function. We spend a great deal of time doing this. But I contend there is a new domain for architecture, and that is economy. When you're building your systems, you need to look at the economy of your architecture because you have a great deal of control over it. So what do I mean by economy of architecture? I mean the same or better outcome for a lower cost. And I'll show you how we can actually do that today. I'm talking about the ability to trial and change the way the system is built during its own lifetime. We need to move away from this model of heavy upfront design, some finger in the air predictions of what capacities we'll need and what profile the application will run, and instead embrace the idea of radical change during its life cycle, funded by cost savings. Now, there's degrees that you can do this depending on whether you built the system yourself or you're using a commercial off-the-shelf system. I'll be showing you options that apply to either. Now, radical changes are possible and they're driven by economics, and more importantly, they're often driven by the appearance of new services, like you saw today, that dramatically lower the cost of some of the undifferentiated heavy lifting of IT. A service that you may have invested significant time, effort and money in building yourself, you could probably consume cheaper from somewhere else. Replace in your system. The other aspect that I think is really interesting, and this is a growing area of interest in the community, is around transactional cost and operational cost. So I have a question. This is the only participation part of the talk today. The first 2 rows will not get wet, so it's not that sort of participation. But I have a question for you, as soon as my little clicker works. There we go. Who knows what their per transaction cost is for their favourite application? Not many people. Who here knows what their cost per hour is to operate systems that they're responsible for? Good. Okay, that's getting better. Who tracks it in real time and sticks it up on a board in the corner? Yep, couple. Very representative of my investigations with customers. Most of us run and operate systems and have no idea what they actually cost from a business-centric perspective. So here's the challenge. I could have gone down this direction for the whole talk. I'm not going to, but I want to give you a little something just to give a teaser as we go. There are some actionable steps that you need to take in this area. The beginner one is simply do it by hand. Sit down with Cost Explorer, figure out your transaction rates and do some rough calculations and either be pleasantly surprised or really, really shocked. Depends. Intermediate, you gather these transaction volumes in real time from your systems and you still calculate by hand. But the advanced one is you monitor in real time. You can plug transaction rates into something like Kinesis Firehose and run Kinesis Analytics on it and pull out some really interesting data in real time. Now, what's my average transaction flow versus my average infrastructure cost, and put it up in the corner and say, hey, dev team, optimise that. That becomes your measure. So just think about things in that term as we go through and optimise some stuff, because you need to make this relevant to your business stakeholders. So let's talk about operational optimisation. This is an interesting one because people don't really think about this very much because, you hire people, they do stuff for you. I pay them, they come in, they do stuff, If they don't do this stuff, they'll do something other stuff. Well, what does this stuff actually cost? So I thought I'd have a bit of an international investigation and say, what does it cost for a systems administrator per hour, this is just converted to US dollars, around the world? And you can see that, life in Brazil as a systems administrator is pretty good. Japan's pretty high as well, but I'm guessing the cost of living is pretty high. But this is just the median system administrators. Now, none of us in this room would ever work with just a median system administrator, would we? No. We don't do median. DBAs are the same. Interestingly, the parity of DBA per hour cost compared to system administrator cost was much closer than I had thought. I don't know how that happened, but again, you've got a big range there. It kind of sucks to be a DBA in Singapore at the moment, but it's really good in Japan. I don't know. But anyway, all these things have a cost. So let's think about what the actual meaning of this cost is. So let's talk about a database upgrade. We should be upgrading our databases on a regular basis to take patches, fixes, performance enhancements, etc. If you're going to do one of these yourself, you're doing a lot of work. You're going to back up the primary, you're going to back up the secondary, you're going to back up the operating system, you're going to back up the server. You're going to try and find the binaries to do the upgrade with. Anyone done that lately? Yeah, that's a fun morning's work right there. Then you're going to create a change record. Then you're going to rehearse it in development because this thing doesn't always go right. Then you're going to do it in staging and make sure it worked properly. Then you'll do it in production on the secondary. Then you'll fail over. Then you'll do it on the primary. Then you'll make sure it's working. And then if you're lucky, you've just spent 8 hours doing something that has no perceivable value except you're now up to date. Or you could do something like RDS and say, well, I'm going to check my window that I want to apply the update in. I'm going to run it in staging, make sure it's okay. Run it in production, make sure it's okay. I'm going to create a notification record just to tell people I'm doing stuff because that's kind of nice. It'll take me maybe an hour, maybe. And the nice thing is when I do it, I have complete control. I choose when this takes place, the nature of it. I can also track at great granularity what happened. I can watch it happen either in real time or save the logs for afterwards and attach it to the change record for auditability. So I've been really lazy and made my life a lot easier, and I've saved the company a truckload of cash depending on where I live. Just that activity is anything from $133 less to $343 less. That's real money. Now you may say, well, Simon, we're going to spend that money anyway. We've got to hire these people, they're not going away. Well, I say that's great, but you could invest that particular chunk of time/money into something else of more value, like maybe tuning your database. Might be a better use of a DBA's time. So what about at the infrastructure layer? What are we going to do there? So one of the big things that people do is invest in storage. And I want to give you a way to save money on your storage without any code changes at all. So this is really relevant to people who are running systems that they might not have code control over. And this is taking advantage of storage tiers, particularly infrequent access. Now you need to understand your usage patterns to take advantage of this, but let's work a real example here. I'm storing 100 terabytes of photos because that's what my app does. Each photo is about 10 meg. And it costs me, in standard S3, $3,292.78 per month. Nice and resilient, safe. I love S3, it's doing a great job, but you know, that's a pretty decent investment in storage cost. What if I know a bit about my data? And I know that my data has a long tail. So, you know, after 30 days, most of the data actually doesn't get accessed because people get bored with the pictures they put up there. 20% of it maybe gets returned once a month, with the odd exception. So I can create a policy. A few clicks and say, hey, apply this policy to my S3 bucket and move stuff across. Bam, 32% saving. No code change, no effort. I'm now spending $2,220.65 per month. That's not bad. So something I want to point out here today is none of what we're talking about here is 5% saving, 10% saving, 50%. We're talking big, meaningful, move the needle savings. Those folks standing at the back, there's heaps of seats around here if you want to sit down too. What about this one? Revisit and right-sizing your EC2 instances. This is a bad habit I see people falling into because we grew up in an age of, well, you buy a server, you live with a server. So you never look at the servers again, do you? You just deploy and you get on with your life. Well, that is not the case in EC2 land. As you saw this week, lots of new instance types to choose from. Do you check on a regular basis whether your instance types match the reality of your workload? Who's done it in the last 6 months? Good. At least every 6 months, if not once a quarter. The updates in the AWS blog saying new instance type available is probably a good cue. You can also use Trusted Advisor for some hints on this, and I'll share some good news for you about Trusted Advisor soon. But let's work an example. Let's take a Windows workload that I have running. And let's compare two instance types. So I've got my M4 4X large, cost me just over $2 an hour to run in Sydney. I've got my M4X large, cost me nearly 30 cents an hour to run in Sydney. Now I'm running my workload and I look at it and I say, well, what's notable about that workload? Well, it kind of pegs out at 15% of the CPU. That's what it does. It doesn't go higher than that. That's its maximum rate for whatever reason. Don't know why, that's just what it does. So I can do a trivial change and change my instance type down to that X large size and test it, because we always want to test and make sure we're doing the right thing. And lo and behold, where am I sitting? I'm sitting about 60%. Now I'm really happy with that because I'm a conservative kind of guy. I don't like running my servers at 90% because weird stuff happens at 90%, doesn't it? It's kind of, gets a bit shady, but 60% is fine. I can peak up and down. I got no trouble before I even start using auto-scaling groups. So I'm pretty comfortable with this. What have I just done? I've saved myself 87% on my EC2 bill. Now, I would contend that for most customers, the EC2 part of the bill is the biggest part. If you go to whoever's paying that bill and say, I've just saved you 87% of your EC2 bill, you will probably get a hug. You might not want a hug, but I'm pretty sure 85% and upwards of savings is the hug zone. That's what I'm calling it. Again, I don't know if that's a good thing or not, but we'll just call it what it is. So you can actually use Trusted Advisor to help you with some of this stuff. It does give you some really good cost optimization hints. And one of the nice ones is the low utilization EC2 instances. Now this is not so much for the example I just gave you. This is for the ones that are pretty much, someone turned them on and they don't use them at all. Like really low network utilization, really low CPU utilization. Take advantage of Trusted Advisor. So let's get a little more fancy, shall we? Spot instances. Who uses spot instances here? There are quite a few. They provide great value for your workloads, but for many people, they're only familiar with using them for maybe dev tests, some highly scalable and embarrassingly parallel processing type work, things that are ephemeral. But did you know you can use it in a different way? And here comes the code. So this is an auto-scaling group launch configuration in CloudFormation. So our first taste of JSON for the morning, just get us up and going. Sorry I didn't convert it to the YAML version, I probably should, but I ran out of time. So this is the launch configuration part of our auto-scaling group. So what do? So we duplicate our auto-scaling group. So we'll now have 2 auto-scaling groups for our application. And we're going to do a hell of a lot of coding. This could take a long time. Tell the boss you might not be available for a week because you're going to do a lot of work. You're going to add 1 line to your launch configuration. And that one line is the spot price. And automatically you have turned this launch configuration, which is a new one, I'll show you a picture soon, into a spot instance-driven autoscale group. So you've probably seen some quizzical looks. This is how it looks. I have one ELB and I have two autoscaling groups. One autoscaling group is my standard on-demand, or it could be an RI autoscaling group doing its work quite happily, but it's really small. My other autoscaling group, though, is my spot instance autoscaling group. And for that, I'm going to bid higher than the market rate, but lower than the on-demand price. Now, one of the benefits of the way the spot market works is even if you bid higher than the spot price, you pay the prevailing rate. So if I bid $1 and the prevailing rate is 50 cents, I pay 50 cents. So I don't have to do any work, which is good. So as long as I'm bidding lower than the on-demand rate and higher than the spot rate, I'm automatically saving money of some description. Now you may say, aha, but Simon, there's spot instances, you might not always have them. And I'll say, yes, you're absolutely right, which is why we will set a CloudWatch alarm on the group in-service instances for the spot instances group and make sure we have enough capacity there. And if we don't, what does that trigger? It triggers our other on-demand autoscaling group. Balancing workload, playing with some stuff, technology, not too shabby. Now we need to understand the price history to make sure we make an intelligent approach here. Luckily, we have the handy-dandy console, which has probably been fancily updated since I made this slide. And we can see what the price history is. This is a good example of one in the Sydney region. 3 AZs, you can see for this particular instance type, the M3 medium, pretty low and steady, isn't it? Doesn't change much. There's a little spike in one spot, but it's not one of those ones that's bouncing all over the place. So I've got pretty good assurance that the price is generally low. So let's work the example here. So I've got two autoscaling groups, spot and on-demand. My on-demand price is about 9 cents-ish an hour for on-demand. My spot price that I've seen in the market is about 1.3 cents. So if I've got a 12-server fleet, if I use it using just on-demand, that's $1.17 an hour. Now, many of you know your hourly cost, which is good. You should all know your hourly cost. If I convert it to this model and aggressively use spot in this scenario, I'm likely to be spending 32 cents an hour, or I've saved 72%. Now this is really nifty because firstly it's kept me out of the hug zone, which I know some of us are not too comfortable in, but we've still saved a lot of money, haven't we? I mean, 72% off your bill, that's something to be thought about. So let me show you another way to save a lot of money on your infrastructure without doing any code changes. Let's talk about developers. We all love developers. Developers work hard. I was once one. And developers work on big projects, but they never work 24/7. I have worked on projects where it's happened for a short period of time, but the quality of code goes down very quick. And the coffee increase is just, it doesn't work out well. So let's think about this. Our developers are not working 24/7. Even if they're working 10 hours a day, I've still got 168 hours that nothing is happening. Shut stuff off. Please. Telling you, shut it off. You will save 70%. It's interesting, a lot of people put a lot of focus on their IT spend on production. Most of the IT spend is actually in dev and test, isn't it? That's the little secret of the industry. So how can you make this easy for yourself? Well, you can automate it. There are many different ways you can use. There is no right way. My imploring to you is to do something. So one example is you can use tagging to start up and shut down, but be careful with this. I'll share an example from an Australian customer, one of my favourite customers, REA Group. They were really advanced in the AWS use and they tagged everything. They said, we're going to write a script, it's going to go through and if it's got the right tag, it gets shut down at night. Awesome. Only problem, there was a little issue with the code, is that if it called the API, didn't get any tags back, it thought, untagged instance, shut it down. So it was a bit of an issue with the API at the time and it was getting no tags back and it was just happily going down and shutting off hundreds of instances. It was actually called the zombie apocalypse. And the really kicker of the story is that the zombie apocalypse only ended when the instance that was running the script killed itself. So, use something, but be careful what you use. Now, I want to give you a list of things to use. It is a completely incomplete list, but it's a good one to take a snapshot of. So you can use Lambda, you can use Data Pipeline, you can use CloudWatch. I'm going to name check an Australian company called Gorilla Stack, who also do stuff in this area. So there are lots of options you have. Turn stuff off, please. Now, another little infrastructure one is caching. Now, caching is one of these weird things in IT. I don't know if you guys have found it, but people are kind of afraid of caching. It's like, oh, it's a bit scary and we didn't learn about it in university and it's unfamiliar to us and you've got to preload caches and what if the cache turns off and all this good stuff. Anyway, it's worth investigating because beyond performance improvements that you can get, and this white paper, the reason I've linked that is that just gives you so much information, way more than I could give you in this session. You can save 90% of your spend. We're in the hug zone again, danger. So think about it. If I've got a database that's a DBM3 large and it's doing 30,000 PIOPS, single AZ, so just one node, and I'm driving it hard, and I flip it to an Elasticache node, it's an order of magnitude cheaper. Wow. And my customers will probably be happier. Yes, got to do a little bit of work. We're getting to the little bit of work zone, but it's something to think about. The other reason I mention it is for a lot of applications today, they do provide a drop-in capability for things like Redis and Memcache. And if you're not using them, you should look into it because you can save big. So let's move into some meaty stuff, the architectural optimization. If you're an architect sitting in this room today, you are unbelievably lucky. You're as lucky as this gentleman here. Because this gentleman is standing there, he's got levers to pull, hasn't he? He can pull them down, he can pull them up. But it's actually really cool. With intelligent decisions, you can pull different levers and get different outcomes. It's awesome. So what are some of the levers you can pull? Well, you can do code changes. You can actually change code. It's actually the best way to fix stuff. The number of times I talk to customers, they're like, well, this application runs terribly and we want to change the infrastructure. And it's like, well, maybe you should just fix the application in the first place. So we can do that, you know. And there are architectural trade-offs to be made. There are way more decisions than you ever had to make before. And on the one hand, that's challenging because you've got to kind of learn more. But the flip side is it's great because you've got more choice and you can make better, more finely honed decisions. And you can test them in real time to see if they make sense. You're not sitting there 12 months before deployment going, oh, I think if I use this kind of approach, it'll be okay. You can say, well, I tried that approach, it didn't work, I'm going to spend a week and change it to something completely different. And it's okay. And it really is okay. So let's talk about some of those levers and some of those tricks you can use. Who here has a web tier? No one has a web tier? Few people have a web tier. We've all got a web tier to do something. So did you know you don't need to have web servers to host your web tier? Because hosting web servers is kind of boring. Unless you're doing a truckload of mod rewrites and other stuff, you're really just spending most of your time patching, feeding, upgrading, and looking after it. So one of the approaches a lot of customers have started to take is to use S3 as their web tier. Because S3 has this capability called static website hosting. Worst name ever, because it's not static. You can run JavaScript, you can do cores, you can host the AWS SDK in there, you can do a whole bunch of active stuff from that website. And you're not patching it, there are no servers to manage, there's no scaling rules to worry about, it just works. Now you may say, but what does that cost me to run, Simon? Well, if we take an average page, and these days an average page has 150 or more objects on it, and the average size per page is exceeded 2 meg. It's actually rapidly growing, which is interesting. Let's say we've got a popular website, 100,000 page views a day, 450 million gets, nearly 6 terabytes of data transfer. I'm paying in Sydney $1,139.43 per month for that. All day, every day, getting that happening for me. Now, remember our example before about what it costs to administer stuff? Well, what am I saving on? Well, I'm not patching web servers anymore, not doing capacity planning, not having to worry so much about my security scanning because the pipeline is much easier to scan, there's less surface area. My rollouts can be much easier, I can do better testing. I'm saving hours per month. So let's get to something really nifty. That's our front end. What about queues? I've been talking about queues since 2011 with AWS customers, and they are awesome for decoupling and availability and scaling and all that sort of stuff. But did you know you can use them to manage cost? Yes, you can. Let's work an example here. Let's trigger our auto-scaling groups based on revenue. Totally different model to think about. So we're going to work an example because it's always easy to work an example to get these through. So we have an app. It's a mobile app. I take photos because that's what I do. And when I take a photo, it gets stored in S3 and something happens to it, and I care not what that might be. In our example, we've got a single M4 large, and that can process 1,000 images in an hour. And I've got an agreement with my customers. It's a freemium service. If you don't pay for me, you get your photo back when you get it back. If you do pay for it, I'll get it back to you within 10 minutes, because that's kind of how we roll. So I have two autoscaling groups here. The autoscaling group at the top, the free queue. So if I'm a free customer, my metadata goes onto the free queue to be processed. And the autoscaling group only spins up when I have 1,000 pieces of work on that queue. So I'm maximising my workload for that hour, aren't I? But I will wait an indeterminate time. If, though, I'm a paid customer, my queue uses a completely different metric. You may not be familiar with this metric because it only came out a little while ago. It's the approximate age of oldest message. So it tells you how aged your queue is. Remember our 10-minute SLA? This says if I'm lagging behind my 10 minutes, spin up instances, process away. Completely different behaviours of two autoscaling groups based on different queue rules. Same customer base. How does this look from a revenue perspective? Well, let's do an example. 2,000 transactions come in. Half of them are free, half of them are premium. So we, in the free mode, only spin up one instance for an hour, and we process those transactions. So our cost is, and here we start reading the zeros, 0.000336 per transaction. Now, if I'm processing on the paid queue, though, I have to spin up 10 instances to get the SLA that I want based upon that throughput. So I'm paying 0.002016. So again, order of magnitude different cost for my paid versus my free people, isn't it? I now need to understand, what am I charging my free people? Nothing. So that's a cost that's burdened on my paid people. What am I charging my paid people? Do I know if I'm making money on any customer? Lots of questions start bubbling in your head. So let's see if we can make this cheaper and better now that we understand what our cost model is. Well, one of the fundamental rules in architecture is the less you have, the cheaper it is and the simpler it tends to be to operate. The ultimate thing is the thing that has no moving parts. It's like a block. So what we want to do is we want to simplify. So I'm going to simplify by moving us to a Lambda-based model. And I'm going to show you the cost implication of this versus just the functionality thing. So what have we done here? You can see there's no queues here, and we've now got two buckets. Why do we have two buckets? Well, we're going to use S3 events, and I'll show you how to configure that shortly. But if we had the one bucket and we're using S3 events, every time we did something to that object, what would happen? It would spin it off and try and do it again. So now we have two buckets. We receive the image into one bucket, do an S3 event that triggers a Lambda function to do my work, and then we store it to a secondary bucket. Now, for our example, I've taken the worst case scenario of how long it takes to process my image. I've given it the largest amount of memory. I've gone as hard as I could in terms of the badness scale, just to give you a realistic example. And I'm now processing my per transaction cost, lots of zeros there. I'm not even going to try and translate it for you and read it to you. 53% savings. I've halved my transaction cost. You take that to your business stakeholder and say, do you know we can now charge our customers 50% less and be more competitive? Or we could take that money and invest it in a marketing campaign, or we could give them a 25% cost saving. Well, it's up to you what you do with the money, but you're now processing better. The other thing you've done is you've taken the queuing out, so we're not paying for that, although it was really negligible. It was literally dollars for what we're talking about here. The other thing I haven't factored into this cost saving is you get with Lambda a free tier forever. In this particular model, that would have given us 71,000 free transactions every month before we even started paying for it. That's pretty good. What's the other thing we've done here? We've now eliminated our 10-minute SLA, haven't we? We now get people stuff almost instantaneously, and they're paying less for it. So how do we set up a S3 notification? Well, it's really tough. It's going to take you forever, you know. You're basically going to jump into here. You can also do it through the command line, etc. And you simply say, hey, I want to create an image processor function that responds to a put request on a particular bucket and triggers a Lambda function. Wow, that was hard. I'm liking this new world. It's so much easier than it used to be. Now you may say, aha, Simon, but the pricing you showed me for your paid tier is higher than your spot tier, isn't it? I will say, yes, it is. But we can double down on that. We can have both. So we can have the Lambda function for our paid tier because it gives us that really nifty controllable SLA, and we can continue to optimize that if we want. And we could also apply all our newfound spot knowledge to our free tier and drive that as low as possible to almost zero. So we can have our cake and eat it too. So this is how you can start to use queues based on economic performance. Now you may say, well, Simon, you've used the easy examples. It's all stateless, just photos. You know, come on, where's the data? Well, I agree. Databases make it hard. Databases are always the trickiest part. So here are some rules of thumb that you need to think about. Firstly, let's stop the religious argument of relational versus NoSQL. The answer is both. Got to tell you. They suit different patterns, different workloads, and you'll often find an opportunity to pull out a particular component and put it into a NoSQL database and vice versa. Use caching liberally. It is an awesome pattern. If you look at any large-scale software development company that are delivering web-scale applications, they have caching everywhere. It's just normal. We need to take advantage of it more. Do not conflate your transactional database with your analytical database. They are not one and the same. There is a reason why Redshift exists and there's a reason why Postgres exists, and they're not for the same reasons, and you need to separate the two. And also, most often, there will be just a few hotspots in your databases, and these are the giveaways to say, aha, that's the bit I need to migrate to something more suitable for that particular workload. So it's not saying, well, this database performs terribly, I'm just going to move the whole thing to Cassandra. Well, that's not going to necessarily fix your problem. You need to pick and choose. So when we pick and choose, we use a dollar value as well as a performance figure to calculate that. So here's an example of a data set. It's a big data set, 3 terabytes, and it's running at 80% read, 20% write. Pretty common workload pattern we see. If I sit down and say, you know what, I'm paying a lot for my multi-AZ RDS for MySQL to do this, I'm spending almost $5,000 a month on it, I can simply move that data set to DynamoDB. I have to make some code changes. Remember, these are some levers we're pulling, but I know I'm getting an almost 40% saving and probably a better performance profile. So again, I can decide which levers to pull when it's worth it. You know, I'm not getting out of bed for less than 5%, quite frankly. So, you know, we've got to have the numbers high here. So this is over 30%. So what's the point here? The point here is that architectures can evolve. They can change. Now, what's one of the biggest challenges of talking to anyone about the whole concept of evolution? I have young children, we talk about evolution. I say, well, why don't I ever see anything change? I was like, well, because it takes millions of years for something to change. You're never going to see it. It's really frustrating. We live in a completely different world in IT. Look at this week for you guys. How much has changed for you in this week? Everything's changed, oh my God. It's good, yeah? Things change really quickly. We as architects and developers need to take advantage of this and evolve our systems really rapidly in response to the stimuli that are around in the world. So I thought, well, let's do a worked example of this and see how this can actually play out. So I thought, let's build a microservice, because microservices are cool, are they not? Yeah, we like microservices, so let's build one. So I thought, let's build one to help us find restrooms. In Australia, we're lucky we have some really good open data sets. Data.gov.au provides one that shows me all the public toilets in Australia by postcode. Awesome. Or zip code, yeah. Handy data set, let me tell you. I was happy when I found it. So I thought, okay, let's build that. And I thought, well, let's take a traditional thought process. I'm going to grab just a language. I've never used Python before. I thought, well, I want to learn Python. I'm a developer, so of course I'll choose the new shiny thing. So I chose Python. Bottle as a framework. MySQL, because I know how to code in MySQL and it's just easy. So I'll go ahead and build that. So I built a microservice. So you can go ahead and laugh at my code, all that sort of stuff. And basically all this microservice does is something easy. It takes in a postcode or a zip code, you might call it, and validates it. They can only be 4 digits in Australia, so it makes it nice and easy. And then it runs a query against my RDS database and says, hey, get me the list, and return it as a JSON payload. Pretty easy. So I coded that up, felt nice about myself. I said, oh, where am I going to deploy this particular microservice? Well, we tend to do what's familiar, so I'm going to deploy it onto EC2. And I'm not going to do it natively, I'm just going to go and use ElasticBeanstalk. So spin up ElasticBeanstalk and deploy it. That's going to give me some awesome stuff. It's going to give me a load balancer, going to give me an auto-scaling group. I'm highly available. I'm going to have a redundant RDS cluster running underneath. I'm looking pretty good. There's some downside there. I don't have any API protection, no throttling, no credentials, no management. Still got to roll my service through and do some patch management, although ElasticBeanstalk helps a lot with that. Still got kind of a heavy storage layer, but this does the job. So let's see how it actually looks if you've never used ElasticBeanstalk before. This is where we have colour and movement. So this is 8 times speed. I'm calling it out because I didn't want to have you sitting here for a while because it takes time for instances to spin up. But this is deploying from my code base there. I'm doing an EB create and it's spinning up the Elastic load balancer, it's spinning up the instances, the auto-scaling groups, the CloudWatch rules, etc. I really like ElasticBeanstalk because it does all that stuff for me. So this will spin up, it'll create all the resources. And I'm a happy little camper, and I'll show you how it works shortly. But we'll just let it spin up. You can see where I did it 8 times speed, because I can't tap dance for as long as this would have taken. It takes a few minutes, because instances take time to spin up. But in general, it'll do it in a few minutes, and away we go, and boom, we're done. Great. So what does it actually do? So if I type in my URL, and I do a /postcode, and then I do a /2000, that's Sydney CBD, there's all the bathrooms. I do Melbourne CBD, where I'm from, 3000, my suburbs, 3185. I'm pretty comfortable. This works, does the job, I'm happy with it. Great. I could have stopped there, but evolution, huh? Things change. So how do I evolve? Well, what's cool? What's useful? What do people like? They like containers. Containerize. We should containerize. So I thought, well, I'm not going to containerize. I'll be lazy. I'll get someone in my office to containerize for me. So Shane Baldacchino, who's one of the SAs in our Melbourne office, said, I'll containerize. And he did. He took my code as it was, put it into ECS and containerized it. It's even the Docker file for your reference. Super complicated. So it was really good because we got to say Docker a lot. And it's fun saying Docker a lot, isn't it? Everyone feels good. Yeah, I said Docker today. Yeah, it's cool. And so what we've got here is something that is pretty much the same as what we had before. The instances do spin up faster, which is nice. But I haven't solved any of my other problems really. But I've evolved it to something a little more modern, perhaps, because I'm using a lighter weight container. I can tune my container better than maybe I could tune my application instances, particularly for such a lightweight microservice. But let's evolve. Let's continue to evolve. Let's respond to stimuli. So let's lambdaize and put API gateway on there as well. So suddenly I've taken a vast step forward. I've said, you know what? I'm over these servers, I'm over these containers. I'm only going to use compute when I need to execute my function. And of course, microservices fit this model perfectly. So I'm only spending money when I'm doing stuff. I'm not patching servers anymore. I'm not having to do maintenance because, the little secret of Docker containers, you still have to patch them. Kind of good to do. I've now got a fully managed API, throttling, performance, all that good stuff, but I've still got this big storage layer down the bottom. So the wise ones amongst you will be going, that's where I'd be evolving next. Because really, you've just got a big lookup table, Simon. Why have you got a SQL database there? And my answer would be, you'd be surprised why people do the things they do. Often it's because it's what we know. It was super easy for me to set that up. So of course, I did that first. So let's take it to the endpoint and NoSQLize it. So we introduced DynamoDB. And now we have no servers, we have no containers, we have no database to manage, we have a completely smooth line with full availability, completely tunable performance management and control. We now get to say serverless a lot, which is way cooler than saying Docker a lot, isn't it? Because you can make people angry because, but there's servers there. There's really servers behind it. It's funny. Well, it's funny to me. The downside of this, and I'll be totally honest with you, is that people get a bit concerned because like, whoa, less familiar deployment model. Let's just ease up there, cowboy. I don't know what's going on here. I'm not used to deploying this way. You've got this crazy NoSQL database. You're deploying these functions as a service. I'm feeling uncomfortable. So I want to show you what the code looks like, and I want to show you how you can use existing frameworks to deploy it. Okay, so that's where we're going with this evolution. So here's what the new code looks like. Here's the new code, much like the old code. What have I done? I've ripped out the MySQL calls that you could see there, the cursor that was there, and I've replaced it with a DynamoDB call. So all I'm doing is connecting using the AWS Python SDK, also known as Boto, into my DynamoDB table. I'm running a query, and I'm still iterating through the items and responding to it. So my message here is that any competent developer can convert from running a relational database to a NoSQL database. It's not that hard. So I've done that here. But you're saying, well, you haven't solved my deployment issue. So I thought, well, that's a good question. And it would have been easy for me to say, well, use an Amazon deployment tool like blah or X or whatever. And you say, well, that's your ecosystem, you're familiar with. So I said, I didn't want to do that. As I said, I'd never used Python before, not familiar with it. So I looked for what are the sort of frameworks that get used for deploying this kind of software. And I came across this one called Zapper. And it appealed to me because it's got such a cool name. Is it Moon Unit Zapper? Is it Frank Zapper? I don't know. But Zapper is a very popular open source deployment mechanism. And I've got to say, it is really cool. And what they did is they said, we've got this deployment framework. We're going to just include the ability to deploy to Amazon Lambda. Awesome. Let's see what that looks like. So what we do is we do a deployment. There's a configuration file behind this with about 3 lines in it. The lines are the credentials I need to use, the S3 bucket, and which environment I want to deploy into. It's not that hard. So we go ahead and we deploy, and this is the real-time video. I haven't sped this up. So we do Zapper deploy prod, and it goes ahead and packages my project up from my laptop that was in Git and sends it up across what was a particularly poor communication line at the time, and it starts to create the Lambda function. It creates a few health check rules for me as well to keep it alive and running for me, which is nice. It will also create an API gateway for me. It does all the plumbing, does all the IAM roles for me, everything. I didn't have to do anything. It was really easy to set up, which is why I wanted to share this with you. It also shares one of those beautiful features of many tools, which is the progress meter that doesn't get to 100%. Don't we love those? And it moves at a funny side. This will finish about, I think it finished about 93%, something like that. But it goes along. And the thing I do like is it does say this step will take a bit, a bit being an interesting measure of time. But this is real time. So it's going ahead and deploying the API gateway. See, 94%, it's good. Done. I've deployed my microservice. How cool was that? So let's go and see what it looks like. So again, I can make a call, but this time I'm curling the API gateway /prod/postcode, 2000, that's Sydney, boom. Let's do Melbourne, boom. Let's do Elstonwick, 3185, boom. Nothing changed, but everything changed. I evolved how I delivered that output. I'm doing it way cheaper, way simpler, way more efficiently, less deployment steps. I've evolved my architecture along the way. Can be done. So that's all the good. What about the bad? There are two anti-patterns I want to share with you because these are things you should not do and I want to encourage you not to do, please. The first one is getting confused between high availability and cost optimization. And I see this happen all the time, particularly driven by product owners who say, it's got to be as cheap as possible. And then you deploy on one node and the node goes down and there's an outage and they say, but it was down. And you said, well, I said it would go down, but it has to be up all the time. So, well, it's a whole different conversation, people. So what you want to do is model for availability, then cost. But there is one really interesting trick you can do for this, in particular related to protecting yourself against AZ interruption. So if we have an application, let's say we want to always maintain 12 instances running for our production load, we need to deploy it in duplicate across multiple AZs with full capacity so that we're never affected. This is a true HA architecture. But there's a little mathematical trick if you're deployed in a region that has 3 or more AZs. So remember, we're protecting against an availability zone level disruption. So in the top model, we've got to run 24 aggregate instances to protect ourselves. In the bottom model, we only have to run 18. Why is that? Because I've only got to run 12 at any one time. So if I lose an AZ, the bottom one still has enough instances running. The top one still has enough instances running. But to get there, I have to spend 25% more. So we can immediately save 25% on a HA configuration just by spreading across 3 AZs if you have them available to you. That is a simple configuration change in your auto-scaling group. Go ahead and do it. Immediately less nodes having to run same aggregate workload. The second gotcha. Who here stores binary large objects in their relational databases? Good, okay. Not many. This happens a lot. One of the benefits of my role is I get to meet with a lot of customers and I see a lot of commercial software and a lot of self-driven software. And this happens a surprising amount. So I'm just going to stand here and say, do not do this. It makes your databases run really bad, really slow, and they're very, very expensive. How expensive, you may ask? Well, let me show you. Let's say we're storing our blobs in a table. We've got 3 rows in our table. User ID, image GUID, and a blob. Nice, lazy programming way to do things. And each image is 2 meg, and I store it in my database, and we're really successful. And I've now got 3 million rows. I've also now got a nearly 6 terabyte database to manage, which is hard and painful and annoying. And I'm also spending $3,279.56 per month to run this in a HA mode with just standard storage. So it ain't cheap. If I architect this the way it should be architected, what would I do with my blobs? I would put them in S3, wouldn't I? That's where blobs belong. And I simply change my table and say, point to where the blob resides and have the code get it from there. And now my database shrinks down to less than 6 gigabytes. My storage cost is far lower. Just to store that storage is just less than $200. And even with all the gets and puts I could possibly need, it's just over $200. So my RDS cost goes down and my aggregate cost has dropped, and I've saved 42% just by doing things the right way the first time. So make sure you avoid that trap. And if you see commercial software that you use doing this, have a stern talk with your provider and encourage them to make it more effective to run. So we've covered a lot today. We've ripped open the donuts and got to the goodness inside. This is a cruel slide before lunch. I apologise for it. Sorry, but hopefully they've got donuts today. I don't know. And what I remind you is we're talking about here is a new domain for architecture. We're talking about the economy of your architecture. Think about how to get the best outcome at the lowest possible cost. Think about how to change it all the time, because you can change it based on economics. And understand what your transactional cost is. Now, as everyone rushes for the door, there is one more thing. Everyone in this session today gets 30 days free Trusted Advisor starting on the 6th of December. Thank you for coming along today. This is my gift to you. It will automatically activate based upon the email address you sign up to reInvent to. If you say to me, but Simon, I use a different email address, give me your card and I'll have it activated on the address that you want. Thank you so much for coming along today. Please fill in your evaluation. I'm happy to answer any questions that people might have, but thank you.